Hey everybody, today's topic is code 43 on my tuned port IROC Z Camaro. These tuned port engines, mine's a 1985, and these engines have a knock sensor and a module for monitoring that, and then it feeds into the ECM and limits spark advance if you start to get into knock. Well, as some of you know, I take road trips with this car, and I just came back from a road trip over to Wisconsin. It's about a 1,200 mile round trip, and on the way back I made a stop in a rest area, 5-10 minute stop, came out, jumped back in the car and go out to merge on the interstate. And I leaned on the throttle kind of hard to merge in, and it seemed like it was really bogging down. It didn't really want to go, so I leaned in it harder, and then finally it took off. Power came up, and at the same time it set a check engine light, and I thought, oh dang, now what? This car's pretty reliable, but it seems like every time I do take a 1,200 mile trip, I get some kind of a glitch somewhere in the line, so you really got to watch out, with a 40-year-old car doing what you're doing. Anyway, I carry a scan tool, and I drove it a couple hundred miles until it was my next chance for a stop, and broke out the scan tool and checked it, and it was a code 43. And it didn't repeat. It's actually hasn't repeated now since I got back. I've got a couple hundred miles on it. So it's intermittent, but I thought maybe it was a good time to go through and explain how this system works, what the trouble tree looks like, and how to diagnose it, assuming it's a consistent failure. I say right now, mine came and went, but what happens is this system has a test mode. And if the engine is hot, operating temperature hot, and you step in, the book says wide open throttle, but they probably define wide open throttle as more than 70 or 80%. It's not on the floor, but because I wasn't on the floor. But it runs a test where it advances the spark until it hits a point where it finds knock and then backs off. And what it does is, if it advances spark and it can't make it knock, it says, whoa, the system's not working and I need to shut it down and set a code. So basically every time you drive the car hot and step in the throttle hard, it'll run this test. Well, and mine failed, yet then it resumed and things were just fine. So I say, we're going to go over to the car, and I'm going to walk through what the service manual shows for my 1985 and what I plan to do next. Because I have a secondary thing, which is I'd like to do some tuning on this car. I want to explore what the calibrations are, and how much margin is there to knock and so forth in the current system. In other words, on a normal day with normal gas, and I step into the throttle, the standard timing on this is 6 degrees. I did some experimenting a couple years ago and said, hey, I could get away with 10 or even 12. At 12, I started to have some drivability issues at part throttle. So I was getting too much, but I would just kind of like to map out what the capabilities are. So anyway, if you go to the ECM, you can back probe one of the connectors, and you can pick up the signal off this knock module. But that means pulling the ECM down, and for what I wanted to do, if I want to go tune things, I'll call it, or make measurements, while I'm driving down the road, it's hard to back probe those ECM terminals and get a good connection. So this module I was doing some digging, and I ordered some terminals. It's a Delphi. Let's see, today it's Aptiv is the company that makes these old terminals, and the module is what they call MetraPack. And so I went to Mauser Electronics and I bought some MetraPack connectors, and I built myself some jumper wires so that I can get in between the spark module and the wiring harness. And then I wanted to do is be able to pick up one of the jumper wires with my voltmeter and perhaps do some data collection on the road. I won't do data collection on the road today, but I'm going to try out my jumper cables and see how things go. So anyway, I'm going to go over now and we'll take a look at the service manual and take a look at what we got under hood. So in my 1985 Chevrolet manual, this is what the system looks like, and they give you some of the intermediate connectors. That's the ECM connector. So the picture shows ECM connector, IP connector. Here's the spark control ESC module. It's got a 5-pin connector, but only 4 of the pins are in use. The knock sensor feeds one. There's a ground. There's power that comes in on pin B. Ignition. And the signal is on pin C, and it's a black wire that goes into the ECM, on my ECM, on B7. Now, I know each year's cars, as the cars got newer, they started changing ECM, so I don't know if it's always on B7. It is in my 1985, so got to be careful there. But it says the code will set if the ECM has seen low voltage at circuit 485, that's that terminal, for more than 4 seconds with the engine running. That voltage drops when it receives a knock signal. So the functional test, once per start, when it's hot and it's at wide open, it checks that signal to see if there's a knock. There's a possibility that it ran this test and it didn't see the knock signal, and so it set that code. It's also possible that I have a bad connection there and the voltage dropped off when it shouldn't have, or it was knocking like crazy as I was accelerating out. I mean, there are 2 or 3 possibilities for that. But the main thing with these charts is this is how the system is supposed to function. Then these are the descriptions for the trouble tree, and then this is the trouble tree, which I'm actually not going to use completely because this is an intermittent. So if you have an intermittent, there are other charts back here going, hey, you should check the connections, you should check other things, because if it's intermittent, the trouble tree, because it won't reset, so the trouble tree won't be able to give you a lot of information. But it would normally tell you to back probe at the ECM, note the voltage, and then, you know, is it over 6 volts, or under 6 volts? And then you check the voltage again and branch down here, and it would pick up if you have a bad ESC module or not. And it walks all the way down through here, checking for opens or shorts that need to be checked. If you don't get a code, there is another test that you can run, which I'm going to actually try. I don't know whether this is going to work, but I'm going to try it. You just get the engine running and warmed up at about 1500 RPM, and then it says tap the engine block in the area of the knock sensor and check for the RPM to drop. And I don't know if I can do that very well, but you know, the challenge here is that, getting to the engine block to, I'll say, to knock on it is pretty tough. I may be able to bump the exhaust manifold or tap on that. I don't have my ramps with me today. Otherwise, I'd have to do is I could get the car up in the air and have it idling and tap it from underneath. But right now, well, we shall see how that works out. But the clearances are kind of tight. I don't know if I can actually get under there with a hammer. So if you come under hood and you get down here, see, this is a relay. I believe that's the fuel pump relay in this car. And behind it, this one here is the spark module. Mounts behind that relay. A little tricky to get to. And then there's the connector. I went ahead and disconnected the connector and connected my jumper wires. You need to be very, very careful that you keep them in order, and that, for me, I had to make sure that the tab is facing the right way so you get the right connections, or you'll burn out the module, right? So the top one here is labeled A on the connector, and that's the one in the book that does not have a connection to it. The one in the middle is the signal to the ECM. That's the red wire, and I put a pigtail off of it so that I could clip my voltmeter to it. And like I say, I don't know that I'll be able to get a knock signal, but we're going to turn it on and see if we get power on it anyway and make that part work. And then I'm going to see if I can get a signal or not. I should also mention that there are a number of different varieties of MetraPack connectors, and these I found by looking in the catalogs. This is called MetraPack 280, and that is because the terminals are supposed to be 2.8 millimeters wide. Something I learned new. And at Mauser you can order them they come off on a strip and you peel them off the strip. They come in different ways, but the part number I ordered came as a strip, and I could order 25 of them for these were like 15 or 20 cents a piece, and I've ordered a batch. If you go down to the local parts store, sometimes you can buy these and they'll want $2 a piece, so that's why I ordered them, and I got some for next time. So I've got the engine up and warming up, and you can see I've got about 9 volts coming out of the module, which should be okay. There's no knock and there's no code, so that seems to be in band. It's over 6 is the answer, so I'm going to let it warm up a little more. Alright, so the engine's almost warmed up. I have a little trick I use once in a while when I'm under the hood. That is, I just put a little shim of cardboard in the throttle to keep it, to raise the idle speed just a little bit. And I got about 9.3 volts. I'm going to tap on the exhaust manifold and see if I can get a response. So I was tapping on the exhaust manifold. I didn't want to do that too hard because I don't want to crack it. I mean, they're pretty strong, but it's still only a casting. So I say tap, tap, tap. But what you could see was with the tap that the voltage was dropping from like 9.3 down into the 8s. You could see I was getting a response, and any time I tapped, the voltage was dropping. I couldn't tell there was an idle speed drop, but I wasn't getting a strong enough response probably. But it was good to see that there was a response. So that's what the spark control circuit looks like on these 85 tune port Camaros. And I don't remember, I think it was a 1989 to 90 breakpoint. The newer cars, they eliminated the spark module and put that function all the way into the ECM, so the sensor connects straight to the ECM without an intermediate module. Right now it looks like it's working, but based on having one of these, I did look up, and as of today, the module is still manufactured and available in the aftermarket. I can buy one, and I think I'm going to go out and buy a spare. I'm starting to get to the point where these cars are getting old enough. I'm about ready to purchase spares of some of the critical electrical stuff that, you know, I'd rather have a spare and put it on the shelf and not use it than not have one and have to go scouring. So in any case, that's what the spark control system looks like. Mine looks like it's okay for the moment. I'm going to take my jumper wires out and put it back together, and as I said, I'll probably come back and I'll probably be experimenting some and collecting some data on how well that system works using my voltmeter. But for today, system's working. I don't have any codes. I'm going to put it back in and get it out on the road. So, hey, that's all for now.